Suppose you give an AI a document to analyze. But what if someone has deliberately planted instructions inside that document to manipulate the AI, to change its behavior, reveal sensitive information, or produce an answer the attacker wants? And what if the AI actually listens? That's a prompt injection attack. Today, we're going to understand exactly how prompt injection works. We'll take a simple document, inject malicious instructions into it, and see how an AI can be manipulated. Then we'll look at the most important defense, separating trusted instructions from untrusted data. Let's start with a completely normal use case. We have a customer support AI. We give it a company's return policy and ask it to summarize the document. The information is straightforward. 30 days for unopened products, 14 days for defective open products, and refunds within 5 business days. Now let's change one thing. Imagine an attacker manages to insert this text into the document. It doesn't necessarily say hack the AI. Instead, it looks like legitimate business information. It claims that the return period has changed to 365 days and that refunds are immediate. Here's where the problem begins. Our application has trusted instructions telling the AI to summarize the policy. But then we put the entire user-provided document into the same conversation. The model now has to interpret both the original task and instruction-like text coming from the document. If the model treats the injected content as authoritative, the result can change. Instead of reporting the actual policy, it may report the attacker-controlled version. The key defense is architectural. We need to establish a clear trust boundary between what the AI should obey and what the AI should analyze. Our system instructions define the AI behavior. The user-provided document, on the other hand, is explicitly treated as untrusted data. So even if the document contains something that looks like an instruction, the model has been told to treat it as content rather than a command. In practice, we can implement this by putting the trusted behavior in the system or developer instruction layer and clearly separating it from external content using delimiters. Here, we're using XML-style tags like instructions and document to create an explicit boundary. Everything inside that instructions section defines how the AI should behave. Everything inside document is treated as untrusted data to analyze, not as instructions to follow. The delimiters don't make the content magically safe. Their purpose is to make the trust boundary explicit, so the model can distinguish instructions from the data it's analyzing. The malicious text is still visible to the model. We're not hiding it. We're just telling the model what role that text has. It's data. It can be analyzed, summarized, or quoted, but it doesn't get to redefine the model's behavior. In our implementation, the trusted behavior lives in the system or developer instruction layer. The user supplies the document separately, and we explicitly establish the document as untrusted content. The injected 365-day statement remains visible inside the document, but doesn't affect the answer. Now the AI can summarize the actual policy while treating the injected instruction as content inside the document. That's the trust boundary in action. But there's one important caveat. Delimiters and system instructions are not a magic security solution. Production systems should also limit what tools an AI can access, validate important outputs, and treat external content as untrusted throughout the application. So remember the core principle. Don't let external content decide what your AI should do. Separate trusted instructions from untrusted data, establish clear boundaries, and give your AI only the authority it actually needs.